Okay, sulfur nucleophiles. Now, we've done oxygen nucleophiles. We've done nitrogen nucleophiles. Okay, now we're going to do sulfur nucleophiles. So the mechanisms are going to be identical, but two of these are more like than the others. Than the other one. Which of these doesn't belong? Well, I guess it depends on what you're thinking about. Like these two, oxygen and nitrogen, are both in the second period, right? But when you see sulfur, do you automatically think, oh, that's in the same column as oxygen? Dmitry Mendeleev did. If you want to be Dmitry Mendeleev, you need to see oxygen and sulfur as very nearly the same thing. Okay, sulfur's a lot bigger, but its chemistry is going to be very similar. So with oxygen, you're expecting there to be 2 bonds and 2 lone pairs of electrons. Sulfur, the same thing. In our alcohol chapter, we had a section on thiols, right? Where thiols are alcohols, but replacing the oxygen with sulfur. Okay, so you see this here, and you think to yourself, oh, well, this is the same mechanism we did before. We did this capping. We made a cyclic acetal with this alcohol, which I'm afraid to say because I don't call it very often. I didn't just go look it up. I think it's ethylene glycol, but if we have an expert watching this and I'm wrong, please stay out of the comment section. I think that's ethylene glycol, but whatever it is, you see the similarity between that and this, right? So the chemistry is identical, and I don't think I want to say any more about it than that. So you can see what we can do with this, with sulfur, with a thiol. We can make a thioacetal, and we can essentially protect a carbonyl carbon. We can do it with a cyclic, right, acetal. We can protect a carbonyl carbon. We can go back and forth with acid, the same way we did in last section 20.7. So why would we introduce this now? What's the interest? Well, first of all, it is another aspect of the periodic table that we can probe, which is great, with very little effort, because we've done this with oxygens. But this next slide, we'll see that we can do one more thing with it. We can take a ketone, and we can convert this to a methylene carbon. That is, we can defunctionalize this, get rid of it, we can reduce it. This is a reduction, right? And we can do that in a way that we could not do with the cyclic acetal. Okay? So a thioacetal is formed via an acid-catalyzed nucleophilic addition mechanism. This is much like what we did with hydrazine. Okay? Rainy nickel transfers H2 molecules to the thioacetal, converting it to an alkane, and this looks a lot like the Clemmensen reduction. Remember the Clemmensen reduction? The Clemmensen reduction was where we took benzene, and you know what? I pulled up whiteboard. I'm going to keep these notes. I pulled up the whiteboard just so that we could use this. Remember this? This is the Clemmensen reduction. And what did we use here? Zinc and mercury. Zinc and mercury. Just a minute here. Clemmensen reduction. We use zinc and mercury. Remember that? Zinc and mercury and HCl. Okay, so let's go back over here. Wait, where are we here? Let's go back here. Write it down. Zinc and mercury and HCl. Remember that? That was in section 19.6, okay? Which I don't have my book with me right now. So, I guess you wouldn't know if I did or not, right? 'Cause you can't see it. All right, so that looks like the Clemmensen reduction, but it's not a Clemmensen reduction. This is a thioacetal, okay? And so I don't think we have a name for this. I don't use the name for it. I don't know what the name is. But it's a reduction all the same. So we've got 3 ways to reduce this. I think this is misspelled. It's with an E, I think. We have 3 ways to reduce this. One with the Clemmensen reduction, which was 19.6. One was with Wolff-Kishner, which we have, I think, in 20.5, chapter 20, section 5, or 20, section 6. And now a third one. What's the difference between this and Wolff-Kishner? What is the difference? I'm not going to tell you. I want you to look at that. What is the difference between this and Wolff-Kishner? All right, and I think I'm not going to cover anything else in this video. Hopefully that's helpful. You should go practice this mechanism, and you'll find that it helps support other mechanisms which you already have in place. Best wishes.